right, so we have h plus 1 over h plus 5 minus h minus 3 over h minus 5 plus 20 over h squared minus 25. All right, so in order for us to add these fractions, we need our common denominator. When we look at our denominators, we have h plus 5, h minus 5.
Go slow, Professor.
Say again?
Go slow.
Oh, I haven't said anything yet. All I said was what we have. And so when I got to this part, that's when I was going to explain better or explain something. So now h squared minus 25, is the difference of squares,
Yes.
which is a combination of our first two denominators, h plus 5, h minus 5. So this would actually be our LCD. Remember, whenever you're talking about the LCD, you take representation of each quantity that you see. Now, if you had powers, I don't think you guys are experiencing that yet, but if you had powers, then you would take the highest power of the quantity that you see. So in other words, let's say if I had h plus 5 squared, then I would have put h plus 5 squared if I had a power. But once again, you guys aren't seeing that, so you don't have to worry about it.
Oh, yes. I think in 7.4, we see that.
Okay.
What happened is I get confused with that too. You have to pick the highest power as your LCD.
Yep.
My question about that is, do you pick the highest coefficient?
Yep. If you have just regular numbers, they're part of your LCD as well.
See, I think that's part of one of the problems I sent you with the early chapters.
Okay, I'll take a look at it. So in that first one, we have h plus 1 over h plus 5. So what is missing from that one? We have h plus 5, so we need h plus or h minus 5. So we multiply top and bottom by h minus 5. And the next one, h minus 3, h plus 5. We have h minus 3 over h plus 5. So what is missing is the h minus 5. So we multiply top and bottom by h minus 5.
How do you know to do that?
Compare the denominator to the LCD. So when I look at this denominator, I said my LCD is going to be this. So what's missing? It was the h minus 5. Remember, whatever you say your LCD is, that means you want to turn each one of your denominators to that LCD. And then here, what we originally had was h plus 5, so what I need to multiply top and bottom by is the h minus 5. Hold on, did I mess up? Oh, that should have been minus 5. I'm sorry. This was h minus 5. So these should be h plus 5s. Sorry about that. So once again, I started off with h plus 5. In order to make it look like this, I need to multiply by h minus 5. The next one I started off with h minus 5, so I then need to multiply by the h plus 5. And then whatever you do to the bottom, of course, you have to do to the top. Now the next one, I don't have to change at all because I already have h plus 5, h minus 5 in the denominator. All right, so before we go any further, questions?
Just keep breaking it down, Professor.
All right, so from here, we need to go ahead and
So we have to FOIL all that.
yep, that's exactly what I was about to say. We have to FOIL out this, And don't forget this minus sign right here.
That's what trips me up. That
It
minus
just,
sign, it goes, you have to distribute it.
that trips out a lot of people. Trips up a lot of people.
It's another
But,
tech, it's another technique when you have to flip the like if you have A plus B, B what A plus B or B plus A, you got to take a negative one out. There's another step that's tripping me up too.
yep,
To get them to match.
yep.
But how do you know to do that?
We'll get there, sir. That's a whole different problem.
Oh
We'll
God.
get. Say what?
Oh God.
So
Man,
yeah.
it was to a point I was about to cry.
Yeah.
Math brain pain.
Say that again.
Math brain pain.
So this we're doing the same thing. I can go ahead and take these off. So we got h squared, 5h, negative 3h, negative 15, and plus 20. Okay. And notice that that minus sign is still sitting here. And that minus sign needs to be distributed into the next parentheses. Oh, well, let's do this. Before I do that, let me go ahead and combine my like terms on the inside of my parentheses. And now I distribute. Always make sure you're careful and you look at everything because it's easy to make a mistake with all of these signs and distribution. Yeah, that plus 20 is still back there. All right, before we go any further, questions?
Nah, one problem takes up a page of paper.
Hey man, you know what I call that, right?
What?
A good time.
Oh God.
So these h squares will cancel for us. Combine your like terms again. We got negative 4h, negative 6h.
I got a
I mean,
question.
negative 2h, excuse me. Give you negative 6h. Yes, sir.
When you say cancel, you mean positive h minus h squared equals 0.
Yes.
Okay.
So we have negative 5 and 15 to be 10. Plus that 20 is 30. And I'll put a 10. All right. I can factor out a negative 6. Remember I mentioned before that if your leading coefficient has a negative, might as well factor that out if it's possible. You know, I mean, if it's coming out with a coefficient, or a factor, I should say. Go ahead and take that out. So if I take out negative 6, I'm left with h minus 5. And notice how that sets you up to be able to cancel out h minus 5. Leaves you with the final answer of negative 6 over h plus 5.
So basically, studying my all this writing to see what you did.
Your questions on that before we go to the next one?
Study all this stuff I just because all I've been doing is writing.
Mm-hmm.
So study review this, see if I can grasp the concepts.
Mm-hmm.
Got you. It took a whole page.
You're welcome, sir. All right.
Oh Lord.
Trying to make sure everybody good before I go ahead and go to the next one.
Let me stop complaining. I'm on YouTube.
All right, so let's look at this next one you had. Must need to reset my phone. My phone was slow today. All right, so we got 8a over a squared minus b squared minus 4 over a minus b plus 4 over b minus a. All right, so this is that scenario that you were referring to.
Yeah.
Mm-hmm. So what I would do first is rewrite, since all of my terms, not all of my terms, each one of my first expressions have a first and then b. I will go ahead and do that same thing with the last one and write a first and then b. Make sure you're careful with your signs. If a is negative in your first expression, then it needs to be negative when you rearrange your terms. And if b is positive, it needs to stay positive. Okay, so sometimes people will make a mistake and write a minus b, wherein that's not what you originally had. You got a negative a and a positive b. Now, when I do my comparison between the two, I recognize that I have opposites. Each one of my signs are opposites of each other. I have positive a and negative b and positive b. So what I would do, a short way of looking at it, a short way of taking care of this type of problem, is multiply top and bottom by -1.
So the average person like me wouldn't know to do a -1.
Well, sir, that's why we're here. Here to drop that knowledge, drop the shortcuts on you. Another way of doing it is to, to go through the whole LCD process and everything like that. But, this is just another way. So -1 times a is a positive a, -1 times b is a minus b. And so, of course, that's a -4 as well. So whenever you have opposites like that, you can multiply it by -1. That'll turn it into, the other expression. But always remember, whatever you do to the bottom, you have to do to the top. So that's why we have a -1. We're multiplying to both top and bottom.
So we still keep that plus sign with that -4?
It's the same thing. Plus -4 or -4 is the same thing.
Okay.
Yeah. I just didn't want to change too much at one time,
Thank you.
Mm-hmm. So now when I look at trying to establish an LCD, we have a difference of squares here. So I have a minus b in my following expressions, but then in my first expression, I have an a plus b. So what I need to do is, that lets me know that my LCD is a plus b, a minus b. And so I will multiply each one of these each one of the following denominators and numerators by a plus b. So that's what we're looking at now. Questions on the process before we go any further?
Be honest with you, Professor, I'm just writing.
Okay. All right. So you want to pause and see if you have any questions? I can wait. It's not a big deal.
Keep going, and what I want to do is go back and just study the problem.
Okay. So we distribute -4 to each. So that'd be 8a minus 4a minus 4b minus 4a minus 4b, a plus b, a minus b. Combine your like terms. We have 8a minus 4a minus 4a. That actually cancels. Then -4b, -4b, -8b. And that's it. All right, questions?
Thank you, Professor.
Problem, not a problem. Anybody else have any other questions on anything?
Anybody else can say I'm the only one having a hard time.
Nobody.
All right.
You're not the only one.
Thank you. I needed a shout out or something.
Look, you doing better than me.
Let's see. What else can we take a shot at?
Hey, thanks again, Professor.
Not a problem, sir. Not a problem. Let's see.
I'm just going to study these. It took up 2 pages. I'm just going to study the notes and see if I can grasp all the concepts you demonstrated.
Mm-hmm. Let's do this one.
I hope the tests don't have problems like this long because it take forever to do.
I can't promise you, sir, because like I told you, I don't make them up.
Gotcha.
You know, this is not like I'm teaching the course, but it's not really my course. You know what I mean? I don't have the academic freedom.
Got you.
In this type of class. Now in my other courses, I get to do what I want to do, but not in this one.
Like this would have took me an hour or longer.
All right, y minus 4 over y squared minus 9. And then we're looking at y over y squared plus 9y plus 18. And if I'm not mistaken, let me check something.
This is what I know so far, Professor.
Mm-hmm.
I know I got the square. I got the difference of, I forget.
Yeah, you're right.
Difference of cube, not square.
Yep, difference of squares.
So it's going to be y squared minus 3 squared.
Mm-hmm.
And the other one, I got the factor at the bottom.
Yep. So
Do that real quick.
You're right, sir. Difference of squares, y plus 3, y minus 3. And here we're going to factor this out. 18, so it's going to be y plus 3, y plus 6. So we need our factors of 18 that will add together and give us 9. So that's why we did 3 and 6. So now my LCD is going to be each different quantities with each different set of parentheses. So it's y plus 3, y minus 3, y plus 6.
Can you say that one more time?
Each different set of parentheses. Notice how we had y plus 3 that appeared twice, and I didn't write y plus 3 twice. Only wrote it that one time. As a part of the LCD.
The LCD are the terms that you see.
Yes, each different set of parentheses that you see.
And what you try to do to have a common LCD is make it look like those three.
Right. So now we're going to go back to our original denominators and see what parentheses they are missing. Well, we can see them right here. You know, when we compare these to the LCD, which parentheses are they missing? This one is missing y plus 6. This one is missing y minus 3. You know, in comparison to the LCD. All right, we good with that before we go further? Right straight.
So the ones that are missing are the ones we need to put in the problem.
Yep, and we're going to multiply the top and the bottom by what's missing. Matter of fact, I'll take it, make sure it stays red.
So y minus 4 would be multiplied by y plus 6.
Yep.
And y, let's see, hold on. Y plus 3, y minus 3, y plus 6 be multiplied to that.
Yep.
Recite this back real quick.
Say that again?
I recite this back real quick to make sure I got the concept.
Yep, I'm listening.
To get my LCD into the problem, I must multiply the missing items from the LCD.
Mm-hmm.
My LCD, LCD needs to look like the LCD needs to look like the problem needs to look like the LCD.
Let's say each denominator needs to look like the LCD.
Okay.
Each denominator. Yep, whatever you saying the LCD is, you want to turn your denominator, each denominator into that.
To make it look like it.
Mm-hmm. All right, are we good to go further? Let me know.
I'm at the red. We good.
Okay, cool. So now here we can go ahead and distribute. You know, we're going to fold this out. Also, don't forget this negative needs to be distributed as well.
Is that a 1 or is it negative y?
Negative y. Well, you know, it depends on how you're looking at it. That negative is a -1, but it's attached. A lot of times people forget that when it's sitting out here in the middle like that, that it's attached to everything in the numerator that follows. It needs to be distributed to everything. So if you want to say -1 is distributed, that's fine. Since I'm distributing a y, I'm just going to distribute the negative with that y because I'm going to have to do that at some point anyway.
Okay.
So like if I go back to the last problem we did, that happened here, you know, and it stayed attached to the 4, then I distributed it. Do we have another one? Yeah, we had one before that. And that's the first thing that we talked about here. That minus sign needs to go and to be distributed to everything in that parenthesis or in that numerator that follows it. And a lot of people make a mistake and they only give the negative to this first term. But in every term that follows has to be affected by that negative.
That's how I mess up doing the homework. So
Mm-hmm.
basically, that's a positive 3.
Yes. Uh-huh.
Oh God.
Yep. Because the only thing about it is I just didn't distribute it until right here. But if you wanted to, you could have done that early. You just got to remember to hold true to what you're doing. And then that means you have a plus here, and then that each time one of those terms will be negative. I would just wait until you get more right here and get this whole thing together, and
Got
then distribute it. That's just easier to not have to worry about incorporating different signs and all the stuff like
yeah,
that.
I didn't think the example, when you do the homework, you have a sample.
Mm-hmm.
And I'm sorry for dominating so much time, folks. I apologize in advance.
Oh,
And
they good, man. I think they appreciate you asking the questions, really.
if you can you scroll back up?
To that eighth one.
Hold on. Right here. Stop with the green arrow
Mm-hmm.
going downward. The sample shows you to put it in parentheses. So you must know as a student when it's that long to break it down and put it in parentheses.
They may be assuming, because I haven't looked at how they do the sample, how they do the explanation. They may be assuming that that you would know certain things or do certain things. I didn't help write the book, so I don't know how it's set up. But that's why I do and try to write down every step. Say what now?
So I need to know to distribute that negative to everything in that parentheses.
Mm-hmm.
All right.
Anything that happens to this numerator that follows. So whatever happens in there, you have to know that this minus sign needs to be distributed to it. Yep. Somebody saying. Okay. Thank you very much. Thank you for letting me know. All right, so we good to go finish off the problem. We good. All right. So let's go ahead and distribute the y minus 4 into the y plus 6. That'll be y squared plus 6y minus 4y minus 24. Then I'll distribute negative y, so it's negative y squared plus 3y. So that's what we're looking at. Any problems so far? All right, combine your like terms. Once again, we see our leading terms cancel out for us. Y squared minus y squared cancels. That leaves me with a 6y minus 4y, which is 2y, plus 3y, that'll be 5y. And that's just minus 24. Well, I didn't leave off anything, right? Just making sure I'm good. Okay. And y plus 3, y minus 3, y plus 6. So I'm gonna recheck my terms, but if that's it. Yeah, that looks like that's it. Questions?
I just got to study the notes.
Right. All right, questions before we do another one. All right, so we have 4 over 5w minus 15.
This is what I see so far, Professor. I have to pull out that 5 from that w minus 15.
Mm-hmm.
Then I go to the 9 minus w squared.
Mm-hmm.
That's 3 squared minus w squared.
Mm-hmm. Yep. So now what I would do, just because I'm looking ahead, I recognize how my W's are in different places as far as order is concerned. Remember we talked about that before? And I would rearrange my terms so that my W is first.
That's the one I've been having a problem with, Professor.
Mm-hmm. So, you know, it would be to your benefit to put your variables in the same order, you know. Even like when we go back to, what one was it? This one. We had A, B, and then, wait, where is it? There you go. We had A, B, and then B, A.
Yeah.
You know, as far as the ordering of our letters. So it helped us to do a cleaner comparison when our variables were in the same order.
So make that a negative A plus B.
Right. So the same thing happens to this next one. So I have W and then my number. So why not in my next one have W first and then my number as well?
Here's my question.
Mm-hmm.
When you go to, I can't do nothing with that because it's a positive now.
Now don't forget though, what you have in your arsenal now, because I told you that it's a possibility. All right? Because remember you had a legitimate thought that I wouldn't know to do that.
Yeah,
But now that I've showed it to you, it's an option.
So multiply by -1.
Uh-huh. Because now you can do something with it. That's a negative W over W squared minus 9.
Then be W squared 3 squared.
Mm-hmm. Which means
W plus 3, W minus 3.
yep.
Now, this is where I get tripped up at.
Uh-huh.
Do I multiply? Let's see, I got 2 minuses. So it'd be the W3 multiplied to the 4.
Well, let's establish our LCD first.
Okay.
Yeah, I don't want to skip steps to make sure everybody's with us. As a matter of fact, I'll write this. Let me write it like this. We started off with 5W minus 15. So we factored it, got this. Then we had W squared minus 9. Factored that, and got this. So that means my LCD is going to be each piece or each different piece that you see needs to be a part of the LCD. So that includes the 5.
Okay.
Mm-hmm.
That's what I was talking about, the coefficient.
Right. That's why I did one like this, because you mentioned it.
So the LCD includes that.
Yep.
This is where it gets tricky at.
Okay.
So I see that I have a W minus 3, W minus 3
Mm-hmm.
in both.
Did you finish?
I'm trying to get worded just right, so
Okay.
I'm not confusing. I have a W minus 3 with the W squared 9 and a W minus 3 in the 5W. Wait, hold on. I'm getting confused. The W plus 3 has to be added to the 5W minus 15 to make it an LCD.
Mm-hmm.
Oh, God, it took some brain cells. All right, now, which one do I multiply to the 4?
Whatever you multiply to the bottom, you have to do to the top as well.
I have a 5.
You already have 5 and W minus 3. In comparison to the LCD, you just said that W plus 3 is missing. So if you're going to multiply that times W plus 3, then you also have to multiply the numerator by W plus 3.
Can you, I'm trying to grasp this.
Mm-hmm.
When you look at the problem, after you
Mm-hmm.
factor it out, okay,
Mm-hmm.
okay.
So when you say, okay, are you good? Or?
No, I'm just,
So once you establish what your LCD is,
mhm.
you're going to look at your original denominators, without your factor denominators, without you adding anything to them, and say, what is missing when I compare it to the LCD? So when I look at that 5 times W minus 3, what's missing in comparison to the LCD is W plus 3.
Yep, that's true. Okay, I see.
And so if that's what's missing, you're going to multiply that times W plus 3. But whatever you multiply to the bottom, you have to also multiply to the top in order to keep your equivalency. So in the second one, you have W plus 3, W minus 3. Comparing that to the LCD, what's missing is just the 5.
The 5.
So you multiply top and bottom by 5.
What part of the brain I'm using on this one, Professor?
Gotta be left side, gotta be left side. So now we can distribute and bring together and simplify and all the good stuff. So this 4W plus 12 minus 5W. Combine your like terms. And that'll be it.
Can you recite LCD, the purpose of the LCD?
It's your common denominator. You cannot add fractions without a common denominator. Now your LCD just ensures you have the smallest, that's least, your smallest common denominator. Now that's not the only one. There are bigger denominators that could be created, but you always want to look for the least common denominator that gives you the smallest terms to deal with.
Your LCD is composed of all the solutions to each individual term.
So, well, the factors.
Factors.
The factors, yeah, would be the better terminology. Each different factor from your combined denominators.
Each factor is the
Mm-hmm.
That includes the coefficient and the terms.
Yes. Mm-hmm. Yep. Those are part of your factorizations. Yep.
And then that composes the LCD.
Yes.
Oh God. I got a clue. Again, I want to apologize to everyone. I'm sorry for hogging up so much time.
Mr. Cooley, if you don't stop apologizing, you good.
I keep telling him, you all right?
Look, You figuring it out, and we sitting up here trying to figure it out.
Thank you.
Yeah.
Questions? Any questions before I throw another one up?
No, sir.
Let's see. That one. All right, so do a few of the other types of problems. I mean, we talked about solving equations already as well, because when you go back to your notes, we're actually out of this chapter. So,
I know.
so trying to prevent from going into a new stuff, a new chapter. Other than that, we just shooting the breeze. So I'm trying to give you guys more, more notes to look at.
What happened
So,
to me, Professor?
say again.
What happened to me was, and I tell everyone, I was so focused on trying to pass factoring.
Mm-hmm.
I spent majority of my time trying to pass that test. I got behind on the other sections.
Oh, it's all good. It's all good, man.
Because I've had a hard time with factoring.
Mm-hmm. It's all right. Trust me. You're not by yourself.
When I passed, it was like playing football. I scored a touchdown when I passed that test.
Yeah. Trust me, sir. You're not by yourself. It's just that when we're doing this stuff, the lectures, like the way the class is set up, I really don't have the luxury to not cover anything multiple days in a row. You know what I mean? Because they want me to cover certain things. So,
I understand.
but we'll be all right. We'll be all right. So this one I think was 7.6, 7.5 or 7.6, one of those sections, wherein they want you to solve. And the first thing you have to find is your LCD. And so I felt like this was still, was a good segue into this section since you were talking about LCD. LCD is a combination of each one of your, a distinct combination of each one of your factors. So in other words, we got y and y minus 6. I wouldn't use this extra y minus y because I already used it over here. So you're just using each one of your different factors. And then I'm going to multiply this LCD to each numerator. Matter of fact, I'll make that red. All right, so notice when you're solving, you can multiply across the equation. In other words, you're not doing top and bottom, we're multiplying across the equation. And we are able to cancel out these denominators. Y and Y cancel. Y minus 6 will cancel. And then here, Y and Y will cancel. And that's what we want. So it's 25 times Y minus 6 minus 25Y equal to 6 times Y minus 6. So make sure we're okay with what happened before we go any further. Distribute 25, distribute the 6. Let me see, 625, this should be 150. Any questions?
I got one.
Mm-hmm.
Do we square that 6y minus 36?
6y minus 36. No, now if you had a y that you were distributing, then it would have been y squared.
I'm talking about the end. Once we did it, when we get to equal 6y minus 36,
Mm-hmm.
we pull out that 6.
Well, are you talking about factoring?
Yes.
Well, you don't have to factor. Remember, we just distributed it.
Okay.
Yeah, so we don't want to take it back out. We want to look to solve now.
All right.
Mm-hmm. So now we're combining like terms and then looking at what we have because we want to. Our goal should now be to get y by itself. We want to get y on one side by itself. So on the left side, 25y minus 25y will cancel, leaving me with just 150. And that's 6y minus 36. Then I'll add 36 to both sides. So 186 is equal to 6y.
Divide by 6.
Yep. I guess I'll keep consistent, turn that
31.
red. So y is equal to 31.
This is way more easier.
Say again.
This is easier.
All right. That's
Once
a good thing, right?
once you find your LCD is y and y minus 6.
Mm-hmm.
All right. You don't use the other y.
Right.
Then take that and multiply that to your numerators, and you solve your problem.
Mm-hmm. Excuse me.
Now, my thing is, if it turns into a long equation where it's like y squared plus something plus another number, are we going to see anything like that?
I don't know how to look through the problems. Look through the problems. But I know if you see it, you'll bring one to my attention.
You said, hey, with the you didn't say it, but the way you worded was like we didn't have A minus B or B plus A or something like that. I was like, hold up, yes we do.
All right, so here we have 16 over t minus 4.
Let me say, you would you would have to factor out that t squared and that 4 squared. That
4t. Uh-huh.
And so it's the best thing to do is write the problem off to the side, then put equal signs in the factors. Okay, so it'd be more organized.
Mm-hmm. So those are our two denominators, t minus 4, t squared minus 4t. So as you mentioned, you want to factor out the t. And what that does is that gives us an LCD of t minus 4. Remember, you take the two different quantities or two different terms.
Now, my question for you, Professor, was were we supposed to put t plus 4, t minus 4?
No, because you had a t that was in each term. So you factored it out. Now, if you had t squared minus 4 without a t back here, then you would have had a difference of squares.
Okay.
Yeah.
So we pull that t out, we get t times t minus 4.
Mm-hmm.
And our other LCD is t minus 4. So the combined LCD is t. So it's the same. Hold on.
Yeah, it's the same as this one.
Yeah.
Right. Because remember, your LCD is going to incorporate the different terms. It's just like, okay, let's go here. Like if I was trying to add or subtract 1 and 1 over 2 plus 1 over 6,
I would
right?
have a common denominator.
Yeah, my least common denominator would be what?
6.
Yeah, it's the same thought process. Now, in this 6 is 2 times 3. So it's the same thought process. So the only thing I do is change this one and multiply this one by 3 in order to change it into the 6. But I don't add a 2 to this. I don't take it to 12, even though I could, because that wouldn't be my least common denominator. So this is the same thought process. This t minus 4 is inside of this denominator right here.
So I got a question, so I can keep it straight in my head. Where I see that t minus 4 in the column, so I just put equal t minus 4.
Mm-hmm. You talking right here?
Yeah, for LCD.
Mm-hmm.
Then when I get down to the next one, I put t times t minus 4.
Mm-hmm.
And LCD consists of
the different quantities or the different factors that you see. So this is already factored as much as possible. There's nothing I can do with that.
yes.
And then this one, it was able to factor out a t. So what has to be a part of my LCD is t minus 4 and t. Those are the different.
Don't write it twice.
Right, right.
Write it once.
Mm-hmm.
Write down once what you see.
Right.
Then once I get my LCD, multiply it to my numerators.
Mm-hmm. And keep in mind that each numerator has to be affected by this, whether it has a denominator or not. So even that -4 on the right needs to be multiplied by that t times t minus 4.
Okay. Can you scroll up real quick? Right there. I was talking, trying to get the concepts in my head.
Mm-hmm.
You scroll back down.
All right. So what's going to happen now? T minus 4 will cancel. T and t minus 4 will cancel in the next one. That'll leave me with just 16t minus 64 equal to -4t times t minus 4.
Give me this over the other stuff.
You got to get to this one, though.
Oh, God. 7.4, if you don't get past 7, this gives you a break. I think they realized that 7.4 was hard and they give you this for a break.
All right, so we can go ahead and distribute -4t into the parentheses. So it's -4t squared minus 16t. So since we have this quadratic setup, we can go ahead and set one side equal to 0. And since I have this as negative, what I would do is go ahead and add that to both sides. And then add this to both sides as well. Set my right side equal to 0. So these will cancel. These will cancel. And also, these will cancel. Leaving me with 4t squared minus 64 equal to 0. All right, questions?
Out. That's a 16.
Say that again.
One in the red, they got slashed out. That's a 16.
Yep, 16t. All right, questions? Any questions? Say that again.
You still have to solve that.
Yep. I was just making sure everybody's with me before I go ahead. I will go ahead and factor out 4.
I got a question.
Yep.
Why we just didn't do difference?
We could have, because I'm going to do it right here. But when you factor out the GCF, then that gives you the opportunity to deal with smaller numbers. That's all. So that's the difference of squares. And set each piece equal to 0. So I'll have a -4 here for my solution. +4 here for my solution.
Oh, that goes back to previous chapter, set to 0.
Mm-hmm. Yep.
What happens to that 4?
Well, remember we're solving for a variable, and there's no variable out here. So all you would be doing is setting 4 equal to 0, which is not true. So there's nothing you can do with that. Now, if you pulled a t out there, now if it was 4t out here, then you would do 4t equal to 0, and now you can solve for t. But we didn't have that, so.
So you have to recognize, you got to see what you're dealing with, have to recognize what you're seeing.
Yep.
That's set notation, isn't it?
No, because set notation is just a way you express your solution set.
Solution set.
Yeah, just another way of expressing your solution set.
I'm using the wrong terminology.
Yeah, it's all good. Now here we have -4 and +4. Don't forget we started off with the denominators. And we have to make sure that our denominators do not produce scenarios in which our solutions aren't true or unable to be used. So if I plug in, well, let's look at our LCD. When I look at my LCD and I set that equal to 0, and solve it, t equal to 0 and t equal to 4. Remember we talked about this that time we had this session. These are values that you cannot use. Because if I were to plug those into my denominator, I will get 0 in my denominator. If I plug 0 in right here, I will get 0 in my denominator. If I plug in 4 right here, or in this first one, I will get 0 in my denominator.
And 0 in the denominator means undefined.
Right, and that's what we cannot have. I didn't talk about in the last problem that we did because the issue didn't come up. So now when we go back to our solutions, notice we have we got t equal to -4 and t equal to +4. But we just said +4 is one of the values we cannot use. So that would not be one of our answers. This is our only solution. All right, questions? All right, so that's 10:45. That is our time. We didn't use up all our time today. Time flies when you're having a good time, right?
Yeah, I feel way better than I was feeling yesterday.
Well, that's a good thing, sir. So, try these out. As I always say, shoot me that email if you have any questions. And other than that, I will see you guys on next class.
See you next class, Professor Tucker.
All right, take care. You guys have a great